Hello, everyone. Welcome. My name is Reid, and I will be your instructor today. Let's talk about promises, async, and the event loop. Now, I want to ask you all a couple questions. Raise your hand if you have been to this hard parts, like the async, promises, and event loop hard parts. You can either physically raise your hand or you can use the raise hand feature. Whatever works for you. Das, okay. Chris, okay, cool. Robin, lovely. And again, good to see you all. I recognize all of you. Welcome back. So good to see you. People note that there are individuals who have been here before. Next question. Raise your hand, whether physically or virtually, if you've been to all hard parts, but just not async. Like you've never been to async, but maybe you've been to a closure, callback, or recursion. Okay, good number of you. That's good. Lovely. Amazing. Lovely. Carolina, good to see you again. Ian, you as well. All right. Hank, hello. Catherine, welcome. Okay, great. Fantastic. A lot of names I recognize. This is actually really lovely. It's like, you know, seeing familiar faces. Okay. Last question. Who has never been to a hard parts before? I mean, this is your first time. You've never been to a hard parts. You're diving in. And you're starting with async. Anybody? Mikey, Shane, Cam, Owen, Amani. Okay, lovely. Sifu, lovely. Okay, well, firstly, I want to say to you, welcome. Thank you for taking the leap and diving in and taking, again, that time to learn. Now, remember I said that async, I would say, is probably one of our harder hard parts. Notice that there were a handful of people who had been to async and are back, which is really important because they're doing the right thing. Because tonight's going to be confusing. We're going to be diving into some really advanced things even beyond JavaScript. We're going to be talking about the browser and a browser environment that is nothing to do with JavaScript. It's going to be a part of like our component here. And so it's going to be hard. Like this is going to be difficult. As I said, this is probably, I would honestly argue, maybe our hardest hard parts. So don't be discouraged if you're confused and lost. Again, ask questions. I'll do my best to, answer them and guide you towards a place of understanding. But, be kind to yourself because like this is going to be pretty difficult. And it just takes repetition. Come back to more of these, and each time you'll just understand more than the last time. So just want to give you a little piece of advice there before we dive in. Like if you are like, man, that's pretty normal. This is hard. So with that, let's actually do it this time. Let's dive in. We've got JavaScript, the hard parts, promises, async, and the event loop. Now, why is this important? Why is this important to know? Why are we even talking about it? Well, firstly, let's talk a little bit about promises. Promises is an extremely useful feature that was provided to us with ES6. ES6 stands for ECMAScript version 6, ECMAScript 6. ECMAScript is the JavaScript governing body because we had a group of individuals who created the JavaScript language back in the mid-90s. But since then, we actually have JavaScript developers and leaders who are on a governing council, basically, that decide what new features get added to the language we use, to JavaScript, right? JavaScript isn't just like this open source language that anyone can it's got people working on it. And so every year they release a new standard. It's called, ECMAScript 6, 7, 8. I think we're at ECMAScript 12 or 13 now. But ECMAScript 6, which was released in 2015, was by far the most significant release we've had probably since JavaScript was created. Because ECMAScript 6 came with so many features that we use in JavaScript on a day-to-day basis. Every year, again, new releases come out, new methods available to you on arrays or objects come out. But a lot of the time, one, you may not even really use them. And two, just because ECMAScript itself said, hey, here are new features, doesn't mean your browser supports it yet, Those are two different things, what your browser will accept and what the language can do. So ES6, all major browsers can use it. I think even Internet Explorer, which is like, at this point, discontinued, pretty much no one's updating it. But if you know anything about Internet Explorer, for the longest time, it was like the one browser that did not want to be standardized to the modern age. So ES6, huge update. We got things like const and let, but we also got things like promises, which we're going to talk about in this workshop. And it's going to make asynchronicity in JavaScript so much smoother. Speaking of asynchronicity, this is what makes dynamic web applications possible. And what does that mean? We'll talk about what is dynamic versus static. But without asynchronicity, let me tell you right now, the internet would be a very boring place. We would not be having as much fun as we do without it. The event loop. How do we handle asynchronicity within JavaScript? We need essentially a set of rules. We need a process in place. And if you understand that process, you're going to understand how to predict asynchronicity within JavaScript. And the event loop is kind of a process built into JavaScript that we can learn and understand to dive deep into asynchronous JavaScript code. And then we're going to talk about the microtask queue, the callback queue, actually not in an opposite order. We're going to talk about the callback queue first, then the microtask queue. We're going to talk about the web browser API. Because remember I said, we're not just in JavaScript land anymore, people. We're not in Kansas anymore. We're in the browser. We're in, so it's different. Things are different here. We're in color here. We were in black and white before. So with that, there's a lot we're going to be diving into this evening. Now, before we can talk about these, advanced JavaScript principles, we have to start with just a basic language, a basic vocabulary that we can all start from. And again, if you've been to hard parts before, you're going to recognize some of the terms we're going over. But if you haven't, this is going to be a good way for you to kind of just see how we're going to diagram, how we're going to, what's what on the board, things of that nature. So let's start by asking, I'm going to ask some questions here. Let's take a look. We see some code on the right here. And it hopefully is readable and understandable, and you can kind of grasp what's being written there on the right. But I'm going to ask you, let's start with Ian. Ian, I'm going to ask, stick with you for most of these questions on this first slide. And it's good to see you again, Ian. So Ian, when we in JavaScript and in pretty much every programming language, we want to take a set of instructions, some code, and bundle it up and then save it later to then, be run when we want it. What do we call that? What is that?
A function or a method?
A function. Yeah, exactly, Ian. A function. So the first thing that's important for us to understand are functions. Functions are just a way for us to bundle code, instructions. We can save it and then later on run it when we need to. So Ian, my next thing is, I said we were going to save it, but there's a place where we save it. What do we call that place in coding?
Global memory or memory?
Global memory. We'll just stick with just memory. Global memory is like a really specific part of memory, which we'll talk about. But yeah, exactly. Memory. So we have functions, we have memory. And honestly, people, if you think about software engineering, that's pretty much software engineering in a nutshell. It really comes down to these two things, right? Software engineering is running, taking functionality or taking data and saving it in memory, and then running functionality on said data. That's software engineering in a nutshell. Taking information, saving it in memory, and then running functions on said data. Okay? We have the two big ones kind of out of the way. Now, JavaScript, when you remember when you were like a kid, right? And you were starting to learn how to read, and you were like, opening up a book, you're taking your finger, you're kind of starting on the top left, going letter by letter, piecing together words become pieced together sentences and paragraphs, etc. You're kind of like tracking where you are. JavaScript actually kind of does the same thing. And it reads your code like English, top down, left to right. And it kind of has a equivalent of that finger, a way to keep track of what line it's on, where is it. Ian, you know what we call that?
Thread of execution.
The thread of execution. Ian, very well said. The thread of execution. So we have our functions, we have our memory, we have our thread of execution. This is important, people, because JavaScript is what's called a single-threaded language. What does that mean? It means it's got one thread. Not all languages are single-threaded. Some languages are multi-threaded. Like, C++ is a multi-threaded language. And why is that important? Well, when you are a single-threaded language, it means you can only do one thing at a time. And I want you to really take that in for a second here, right? JavaScript can only do one thing at a time because it is single-threaded. Again, languages like C++, which are multi-threaded, can do more than one thing at a time, but not JavaScript. There are trade-offs to that, pros and cons. But one of the pros, I would say, is it allows us to really have a much easier time keeping track of what JavaScript is doing at any given moment, because it can only do one thing. So what is that one thing? Okay. Now, again, we call it thread of execution. At Codesmith, you may hear thread of execution abbreviated to the word toe, thread of execution. But if you go to an interview or you're talking to an engineer outside of Codesmith and you call this the JavaScript toe, you say toe, they're gonna be like, what are you talking about? And what is your deal? So know that you could call it toe here. We call it toe. You could say thread of execution. You'd say thread, but outside of this space, I don't think toe has caught on yet. But if you're out there and someone's like, yeah, the toe, know that started here and let us know, because I will be particularly proud if that starts for some reason becoming a thing in the engineering world. Okay, with that, let's go into this piece of code here. We have the code on the bottom left. One thing I want you guys, if you ever can't see something, you need me to scroll up, scroll down, because often I can see it on my screen, but I've been told oh, it's cut off at the bottom on yours. So if it's ever cut off at the bottom, let me know. And I'll scroll around, So we have a blank board right now. We need to do some setup. So let's do it. Let's go with DOS. DOS, you're going to help me kind of set up our initial board here and kind of go through our code snippet, okay?
Okay.
Okay, cool. So DOS, as I mentioned, and as Ian mentioned, we are going to be saving information in an area to be utilized later. We're going to initialize kind of our code in the global space, and I'll talk about that in a second. But where are we going to store data while we're in the global space?
Global memory.
Global memory, exactly correct. And let's put that over here. And thank the Lord that this app straighten lines for you, because I would be a mess if I had to draw straight lines myself. Okay, so we're going to have global memory. And so, friends, this area here is global memory. That's where we'll be storing data when we're in the global space. Next up, DOS. When we run code, we're going to be, again, running code in a certain environment in the global space. What's that environment called?
Global execution context.
Exactly correct. The global execution context. And an execution context, again, is just a space essentially in memory where the JavaScript engine has an environment where it's running your code. So let's do that. So essentially, kind of like everything else on the board is going to be our global execution context. Also, I'm looking now at the screen. I realize that this line is so not straight. So I mentioned a straight line and I didn't even get a straight line. So there's that. I got to work on that. But it better than it would have been. if it didn't, do a little correction for me. Okay, so we have our global execution context. Now, the next thing, Das, I need your help with here is, remember I said JavaScript has kind of like a finger it uses to keep track of. Remember what that actually is called?
Thread of execution.
Nice. Thread of execution. I'm going to kind of show the thread of execution as this green arrow, and I'll write, toe on the board so you recognize that that means thread of execution, but that's kind of what we'll be using as we diagram. There's one more piece, Das, I actually didn't talk about on the last slide with Ian, that I'm wondering if you maybe remember. We're going to need to utilize a structure within the JavaScript engine to keep track of kind of where we are and which execution context we're in. Do you remember what that structure is called?
Call stack.
The call stack. Yes, people. Well done, Das, the call stack. So I'm going to kind of write the call stack over here. And the call stack at the bottom is this, what we call stack frame. And it begins in the global space. So just the thing you all need to realize is that whenever we start our code, like we just say run, run our code, we always begin in the global space. And we are going to maybe move away from there and come back to it at some point, but we always launch our code in the global space. This is the most outer space of our outer area of our code. We're not in outer space, but we are in an outer area of our code. And that's called global. Now, Das, I'll get back to you in just a second, but I want to do just a quick kind of review of what the call stack is. The call stack is what's known as a last in, that's so horrible, last in, first out structure. Last in, first out, LIFO, a LIFO structure. I've heard people say LIFO. I'm a LIFO guy. So this is a last in, first out structure. What does that mean? For those that have been to my hard parts before, you know this analogy. I'm sure it makes you just as hungry as I get, but I got to go over it because it connects with me so much. It's Pancake Sunday. You wake up on Sunday, you're making pancakes. Yes, Hank. Hank's got a pancake picture up. He's got the call stack ready. Okay, so exactly. So you wake up on Sunday, it's Pancake Sunday. You built the batter, you're getting you put some chocolate chips in there, or you put some fruit. Crazy. Okay, so you put some chocolate chips in there. You're going to be making a stack of pancakes. And I am talking about big pancakes. I'm talking like not your silver dollar. I'm talking like as wide as the pancakes. So you make a pancake, right? And you put it on a plate where you're going to be building your stack of pancakes. So first pancake you make is now at the first pancake at the stack, the bottom of the stack. And you keep going, right? Second pancake you make goes on top of that. Third pancake on top of that, etc. Until you get to your final pancake. You wrapped up, you put the last pieces of your batter, you make your pancake, and you put that at the top. So now you have your stack of pancakes. And here's the deal. Now you're ready to actually eat the pancake. You're ready to dive in. And in this analogy, and in the real world, there's no picking out a pancake in the middle, right? We don't do that because we're not crazy like that, right? We go to the top of our stack, we grab the top pancake, which was the last pancake we made, and we eat that, and we work our way down the stack. The call stack is the same way. Whatever stack frame is at the top of our call stack is where our thread is currently doing work. So if you're ever confused, like where are we? Which execution context am I in? Which stack frame am I in? Look at the call stack on our diagram here. Whatever stack frame is at the top is where we are, where our code is. And this analogy has always reminded me that when you eat a stack of pancakes, the last pancake you eat was the first one you made, which is like, depending how fast you eat pancakes, kind of like the saddest, oldest pancake left. And that's how you end your pancake brunch with. It's kind of like, a little depressing if you think about it. But That being said, the rules still apply. The first stack frame we put on is always global. So that's always, the bottom of our call stack. But in this case, because there's no stack frames above it, it's also, the top. So whatever stack frame's at the top, that's where our thread is. Now, Das, a couple questions for you. There are some technical terms we use when we're talking about adding or removing stack frames to the call stack. When we want to add a stack frame to the call stack, what do we say? What's that term?
Push.
Push. Well said. Push. So people, that is the technical term. When we are adding a stack frame to the call stack, we push the stack frame on. When we're done with that stack frame and we want to remove it, what's the term for that, Das?
Pop.
Exactly. Well done. So we have pop. So you push on, so you push the stack frame on, you pop the stack frame off. Push on, pop off. Good. Can I get a thumbs if this is clear so far, if you're grasping what we're going through? Okay, good. Awesome. Okay, with that, we're going to dive in and go through our code. Das, you are, again, a victim of your own success. So let's keep it rolling here. Line one, using that good technical communication I know you got, let's go through this code.
Declare constant label num and assign that to value of 3. And we're going to store that into our global memory.
Lovely. Let's do this color. Okay.
And declare function label multiple by 2. And we're going to store the function definition into our global memory.
Awesome. So let me go over that real quick, Das, because excellently said. So Das said we're going to store, or declare or create the function multiply by 2 and store its function definition in global memory. So what does that mean? Let's go take a look at our multiply by 2 function. All of the information between these yellow parentheses I just drew, kind of the function body, that information is also called the function definition. And what JavaScript does when it sees a function declaration, when it sees a function being created, is it bundles all of that information between this orange parentheses and stores it in memory at the label, for example, multiply by 2. So when we call multiply by 2, it's going to go look, and it's going to look at kind of the information in those orange parentheses. We call that, again, function definition, and we draw that as like an F in a box with an arrow through it. Okay? So if you ever see this F with an arrow, we're talking about a function definition. Okay? Now, Das, we were on line 2. What line of code is JavaScript going to go to next?
Jump to line 6.
Exactly, people. Notice we do not go to line 3 or line 4. Das, why don't we go to line 3 or line 4?
Because line 3, 4, 5, those are part of the definition.
Right. And so when would we, for example, go inside of that function definition?
Whenever we invoke the function multiply by 2.
Exactly. People, we didn't call the function. We just created it. We declared it and we created it and we stored it in memory. But until we actually call the function, invoke the function, tell JavaScript, run this code, run this function, until that happens, the thread is not going into the function definition. It's going to store that information in memory and go down to line 6. So what's happening on line 6, Das?
We're declaring constant output and assign that to evaluated result of invoking multiply by 2 with argument num.
Lovely. And where are we storing that?
We're going to store that into global memory.
Awesome. Okay, people. So Das said that very beautifully. I want you to take note because it's a really strong way of explaining what's happening on line 6 and then eventually line 7. So as I said, we're declaring a variable output in global memory, and we are assigning it the evaluated result of invoking multiply by 2 with the argument of num. I'm going to say it again because it's a really good way of saying what's happening there. We are declaring a variable output in global memory, and we are assigning it the evaluated result, because we haven't evaluated it yet, but we will, but we're assigning it the evaluated result of invoking multiply by 2, passing in the argument of num. Okay. Now, DOS, when we invoke a function, we're going to have some work we need to do, some setup we need to do. But in the meantime, what is output equal to?
It is undefined.
Exactly. Output is undefined for now. We're going to get some information back that might change that. But for now, it's undefined. I'm going to abbreviate undefined with a bunch of ellipses, just a bunch of dots. So if you see a bunch of dots like this, just know I mean undefined. Okay. Dots, we've invoked a function. So let me ask you, I'm sure other people are aware of this, but I'm going to ask you, when we invoke a function, we are creating a new what?
Local execution context.
Local execution context. Exactly correct. So let me use this green. Okay. Put a little local memory in here. And this is for people. The local execution context is extremely similar to the global execution context. Once we move past global, once we've invoked a function, you can kind of think of it a little bit like Inception, like a dream within a dream. This is an execution context within an execution context. We just have a space now to run this function within the global space. And we may even have, maybe not in this workshop, we'll see, but you go to recursion, for example, you might have an execution context in there, and then one in there, etc. So we have opened up a new local execution context, which means we have some work we need to do on the call stack, because the call stack has to correlate to with, what we're doing with our execution context, where the thread should be. So DOS, what do we need to do with the call stack?
So we need to push the stack frame of multiply by 2 into our call stack.
Exactly. Okay, lovely. So that means our thread has now entered this local execution context. What's the first thing we need to do, DOS, now that we've entered the body of this function or this execution context?
So we need to pair the parameters and arguments.
Exactly. Whenever we invoke a function, once we've done the setup on the call stack, our thread's now in that local execution context. The first thing we need to do is pair our arguments and our parameters. So DOS, what are they and where are we storing that?
So our parameter is input number, and that is assigned to num. And we're going to store that into our local memory.
Beautiful. And the reason, DOS, right, you knew that is because you looked up here and you saw that this is the parameter, right? So you said num. What is num, though, really?
Oh, num is 3.
Exactly. So again, a good thing to note when we say, num, we see a variable name. What we're really passing is its value, not the label itself. We write the label, but then JavaScript will then pass its value. So that number is 3. And what do we do next?
And now we need to declare a constant label result, which is assigned to input num times 2, which is same as 3 times 2.
And where are we storing this?
We're going to store that into our local memory.
Exactly. So result is what?
6.
Lovely. What do we do next?
Now we need to return our result back to global memory for to the output.
Exactly. So output is no longer undefined. It is what?
6.
6. Okay, now people, for those that don't know, how do we just get here? Result is a JavaScript keyword, a very powerful keyword, okay? What result tells JavaScript is, one, firstly, whatever execution context I'm currently in, I'm out. I'm done on this, okay? So if you see return, it means I'm done with the execution context I'm in. You need to, the thread needs to be pulled out and move back into whatever stack frame was below the current stack frame. So, for example, if we had a bunch of code between lines 4 and 5, it would never get seen, ever get seen. You could write a million lines of code between lines 4 and 5. You hit that return statement, we're out. We're not going to line, whatever code we've written in between there. Okay. Whatever values on the same line as the return keyword is the value that gets returned out of the current execution context to wherever this function was called. Now, we know, right, looking here, that this function was called on line 6. So we're returning result, which is 6, to the place where it was called, which is this variable name output. So now output in global memory is the value 6. DOS, now that we have finished this execution context, we have some cleanup to do. What's that cleanup?
Garbage collection or local.
Okay. Okay, what else?
And we need to pop off our multiply by 2 from call stack.
Okay.
And thread execution is to leave out to the global execution context.
Exactly. And what line of code do we go next, DOS?
7.
Lovely. DOS, excellent job. I'm going to take it over from here. Let's give a round of applause to DOS for legitimately crushing it. Show some love in the chat, whatever. Like that was amazingly done, DOS. Great technical communication. So just to kind of recap that last piece there, DOS mentioned garbage collection. That is the technical term for what our JavaScript engine does when it's talking about kind of memory management and deletion. So in JavaScript's a very developer-friendly language, meaning it kind of does a lot of the hard work. Hard work's not the right word at all. A lot of the little nitty-gritty details of memory allocation for you. Not all languages are like that, right? Other languages, you have to be very specific in the type of memory you're allocating or removing. But JavaScript, it really kind of lets you, we have dynamic memory, not static memory, just kind of lets you flow. And so in certain languages, when you're ready to remove something from memory, you tell the engine, remove this from memory, garbage collect it. But JavaScript doesn't work that way. Rather, when a piece of information in JavaScript is either asked to be deleted, you could use the delete keyword. There is a delete keyword. Or when information is what we call orphaned. It's a really sad way of saying when there's nothing pointing to this piece of information in memory, it is an orphaned piece of information in memory, then JavaScript knows internally it needs to remove it from memory at some point. But when that exact moment happens, we don't know. It might happen in 3 milliseconds or 10 milliseconds or in 30 milliseconds, whenever. But at some point, the JavaScript engine will go through all the orphan data or the data it's been told to delete and remove it from memory. What you need to know is that the moment that data is either orphaned or asked to be deleted, even if it has not been deleted quite yet, actually from memory, it's gone. We don't get to access it anymore. So once we've moved on, once we have said, this piece of information has been eligible for garbage collection, and I like eligible for garbage collection because I want you to be very clear, it's not in that exact moment, but it's going to be, it's eligible for garbage collection. That's the same thing as for all intents and purposes saying it's gone. We don't have access to it anymore, okay? So garbage collected, which is like those red X's I put there, and then pop. We pop the stack frame off, we hit that return keyword, we're done in this execution context, which means we are popping the stack frame off. So I wrote a little, red line through it, wrote pop, and then our thread returns back to global because whatever is right, the stack frame underneath the stack frame that was popped is where our thread goes to next. So we return back to global. Georgia, I'll get to you just a second. Keep your hand up. Just to show you very quickly on line 7, just so everyone's aware, we're going to be doing essentially the exact same thing again, but I'll do it very quickly with you, just so we can kind of dive in. So on line, let me use this one. On line 7, we see this variable new output, and we're going to declare this variable in global memory and assign it the evaluated result of invoking multiply by 2, pass in the argument of 10. That will be undefined for now. We create a new local execution context. With its own little local memory. We're going to push that stack frame on the call stack. Our thread enters this execution context because that's the stack frame at the top. Whatever stack frame is at the top is where our thread is. The first thing we want to do is pair our arguments and our parameters. So input number is 10. And then we go from there. Result is in local memory. That's going to be equal to input number times 2. So 10 times 2, which is 20. And then we hit the return result, which then returns this information to where it was called. So new output is now the number 20. And then we have some cleanup to do. I'll start with, we kind of pop multiply by 2 off the call stack. This local execution context becomes eligible for garbage collection, and our thread returns out to global. And then we are done with this snippet of code. Cool? All right, let's go to some questions. Let's go to Giorgio.
I just had a quick question about the return keyword. So like most of the time I see that it returns something, like for here, like return result, but I saw an example where it was just the return keyword. So is that like just to exit the execution context, or is it still going to return global memory?
Yeah, sometimes you might just want to bounce out. Like there are definitely aspects of like recursion probably where, and not to confuse anyone with any terminology, definitely check out our recursion workshop. But like if you hit a certain condition, we call it base case, that you're like, I just want to be, once I hit this condition, I'm done here. Then you could just write, return. But one thing I do want everyone to know is, here's a little trivia question for you, Giorgio. I'm going to ask you a question here. Let's say we didn't have line 4, okay?
Mm-hmm.
If I were to, let's get rid of line 7 for a second. Let's say I just want to console log output. What do you, because there's no return keyword in multiply by 2 anymore, right? Mm-hmm. So what do you think will be console logged if on line 7?
I think it would be like undefined.
Exactly correct. So Giorgio, really, really great answer. So 2 things I want everyone to understand. In a function, if you don't put a return keyword, it's, we all know that functions end. We get to the end of a function, we go, the JavaScript goes, I'm out, right? It doesn't just sit there going, where the heck's the return keyword? It's done. And that's because JavaScript, if it doesn't see a return keyword, adds what's called an implicit return. Doesn't see a return keyword, it's going to go, okay, I'm just going to basically add a return keyword there. You won't see it, but I'll hit this implicit return that just exists. If it never sees a return keyword, it'll be at the end of the function body, which is why if there is information we want to return, we write explicit return statements. If there is information we want to return. This is an explicit return statement versus an implicit. And exactly correct to Giorgio's point. Remember how earlier, this is why sometimes different instructors may say different things when it comes to when we initially invoke a function. So like on line 6, some instructors might say, oh, well, output, when we first invoke it, its value is uninitialized, but I say it's undefined, right? And then it might change. because that's my point. If we don't return a value out of the execution context, out of multiply by 2, then undefined doesn't change. It just stays undefined. But if we return a value like 6, then it goes from undefined to 6. Hence why I do think it's important to say that when you invoke a function and assign it to a variable, or rather kind of flip that, a variable assigned to the evaluated result of a function call, initially it's undefined. And then if it gets data back, it changes. Otherwise, it just stays undefined. Does that answer your question, Giorgio?
Yeah, okay. Thank you. Yeah, it makes sense.
Excellent. Okay, people, let's keep it going. Hopefully we're all understanding what we're going through so far, this kind of common terminology, because we're now really going to dive into asynchronicity. And asynchronicity is the backbone of modern web development in JavaScript. Because here's the deal. Before we had asynchronicity, we weren't capable of doing what's called creating dynamic web pages. And what does a dynamic web page mean? Let's say you go to Twitter. When you're on Twitter, you can look and interact with Twitter and see things like, you know, likes increasing on a comment, comments being thrown on, you know, retweet symbol increasing. You can, you know, still interact with the page while data is being updated, right? That is all because of asynchronous JavaScript. If we didn't have that, we would have websites more like static websites. And what is a static site? The best example for me, for you to kind of grasp your head around what that looks like, is like Wikipedia. Wikipedia is pretty much a static website. It's kind of like if you took a page out of a book and just like put it on your computer, like in your browser, and looked at it, you know, in your browser. But there's no dynamic functionality occurring, right? It's just usually text and maybe some hypertext links and things of that nature, but you're not having like dynamic data updated as you kind of scroll through Wikipedia, right? Not to say, I mean, Wikipedia obviously is great, and maybe there is some dynamic functionality to it, but you get the gist. It's basically just like a static site. It's not much going on in terms of active updates. But that's really not how we experience the web anymore. Most of our websites are not Wikipedia. Most of our websites are closer to like Twitter, right? Where things are constantly being updated. So if we look at the example on the right here, let's say we had a function called get tweets. Don't worry about the intricacies, you know, the details of how you would actually get a tweet from like a Twitter server. All I want you to understand is when we invoke this function get tweets, which function we've written, you know, the definition, we've written on lines of code before this slide. You know, let's just say I've written it already. Don't worry about the details. But what it does is it goes and can, you know, communicates. It tells JavaScript, I want you to communicate to Twitter and get Will's first tweet, or the tweet maybe with the ID of 1, for example. And let's say that that takes 350 milliseconds. And just so everyone's clear, there are 1,000 milliseconds in a second. So 350 milliseconds, 0.35 seconds, which may not sound like much, but in computing time, that's an eternity. That's a long time for one request, for one tweet, taking 1/3 of a second. Because think about how many tweets you look at, right? So let's say if when it's making that request, we couldn't do anything. So you'd go to Twitter. The first thing Twitter is going to do is try to get tweets for you. Otherwise, not much is happening on Twitter, right? So you go, and what if you look at Twitter and then there's just a white screen? You would leave, right? Think about it. I guarantee you, when you go to google.com and you are searching for some resource, you click the first link. If that link does not load in the first 3 to 5 seconds, you're clicking back and you're going to the next link. And that's just modern web development, right? We want it and we want it now. We have short attention spans. There's something called a bounce rate, which is the percentage of users that come to your site and leave. And statistics show that once you hit 3 seconds, you can pretty much guarantee 90% of your users are gone if they have to wait longer than 3 seconds. That's how we are now. Okay, we don't wait for websites anymore. Okay, so if we went to a website and it took, 350 milliseconds, and then that compounded and seconds were going by, we wouldn't stay. And that's kind of the big benefit behind asynchronous JavaScript. It's going to allow us to go do other tasks while that, while our browser is talking to Twitter's server and try to get that information, we can do things like load the page and let other things start to be, dynamically update on our website. Because so long as you have something happening on the page, a user's way more likely to stay, right? You ever see like even something as simple as like a loading bar? As long as you see that something is telling you something's happening, you're way more likely to stay there. And so we're going to figure out now, how can we do that? How can we let some work be done in the background that still allows other work for JavaScript to do and allows us, basically tells us, hey, you should stick around because things are working, things are happening. We'll get there. So let's go through that. The first way we're going to talk about is utilizing callbacks. Callbacks are one way that we have access to running asynchronous code in JavaScript. And setTimeout is a function that is built into JavaScript. We never wrote, like you and I, when we're using setTimeout, we didn't write the logic for this function. So we're calling it right here, setTimeout, but just know that it's built into the JavaScript engine, okay? Now, setTimeout usually takes 2 arguments. You can add more, but we're going to focus on the first 2. The first argument is going to be a function definition. Okay? The first argument we pass into setTimeout is a function definition. The second argument is the number of milliseconds we want to go by before we call the function. That's the first argument. So basically we're saying, okay, I would like, for setTimeout, saying I would like in 1,000 milliseconds to invoke the function print hello. Does that make sense? setTimeout, it's 2 arguments. The first one's a function definition. The second one's how many milliseconds do we want to invoke that function. So knowing that, taking a look at this code here, Carolina, good to see you again. Last time we built out your game.
Yes.
So Carolina, let me ask you, what order do you think we're going to kind of see our console logs here?
Okay, let's see. The function. Okay, should I go from the top? I'm just thinking the function definition gets stored.
Mm-hmm.
And then, so that goes to memory. Then it says set timeout, which also is a function definition, about 1,000 milliseconds. And then, so part of this also gets stored in local memory. I'm just trying to think how would that work. So I'm thinking that maybe console log gets print first, me first, and then while that gets print hello, and depends how fast. Oh, okay, so then this gets invoked. Oh, wait a minute. Okay, so I'm trying to think. So
you got it.
Okay. So if this gets invoked, print hello goes. That's not the right way. So invokes the function print hello.
Here's the main question, right? This is really what it boils down to. We know that JavaScript goes line by line, top down. So you are exactly correct, right? We're going to be on our first line here. It's going to say, okay, we have this function print hello, store it in global memory, store, a label print hello. Its value is a function definition. It's going to go to that line, the next line, the set timeout, because that's the order it goes to. So here's the critical question. Do you think that set timeout, because it says here, basically what set timeout is saying here is I want JavaScript to invoke the print hello
To invoke.
function in 1,000 milliseconds, in 1 second. You think that JavaScript sits there for 1 full second, invokes the print hello, so then logs hello, and then moves on to the next part and then logs me first? Or do you think it goes, okay, cool, well, you go do your thing for 1,000 milliseconds, I want to move on, and then when you've hit your 1,000 milliseconds, then I'll work with you? What do you think?
The latter, like the latter. So because it's a callback, set timeout is a callback, it kind of sends it to do its work. And then in the meantime, moves to line 3 and prints me first. And then if by that time, the callback has finished its work, then it will print hello in whatever time it is.
Carolina?
But, okay, nice.
Very good. Exactly correct. You crushed it. Well done, Carolina. That is exactly it. Because set timeout, just like Carolina said, is utilizing callbacks. Callbacks, again, are a way we can perform asynchronous JavaScript in JavaScript. We're going to talk about the details of where this goes, but Carolina's spot on. We see set timeout, and set timeout's going to go, okay, cool, here's the deal, JavaScript. I have a function, print hello, that I know I need to run it in 1,000 milliseconds. So JavaScript is going to say, cool, go do that. You go do that, but I'm moving on from you. And I'm going to line 3, and I'm going to log me first. So we'll see, you know, me first. And then, I mean, honestly, let's say between lines 2 and lines 3, that's probably 1 millisecond. We're going to then wait for 999 milliseconds. So we're going to wait because we still have to do the 1,000. That has to happen. Nothing's going to happen until the, you know, JavaScript knows 1,000 milliseconds has gone on. So then in 999 more milliseconds, how it goes on, and then we'll see hello underneath it. Exactly. Because JavaScript is moving on. And then we're going on to line 3. So we'll see line 3 because console log is synchronous. You know, that's a normal function. So we console log me first, and then 999 milliseconds later, print hello gets invoked. What does print hello do? Console logs hello. Okay. So Joanne, I see your hand. I'll give you 1 second right after this next example, but keep it up, okay? But here's a twist, Carolina. I'm going to ask you this. I'm going to stay on you. What do you think is going to happen here? Take a look at the little subtle difference here. Set timeout is no longer 1,000 milliseconds. It has now been set to 0. So what order? And again, safe space. I mean, you know, you're learning here, so don't. There's really, you know, no. Just take your best guess. What order do you think we're going to see our console logs?
Well, my first question, this is the first time I attend this workshop, but my first question is like, well, 0 is not a millisecond, is it?
No, 0 is 0, right? Exactly. That's what's going to happen now because we don't have any, you know, it's 0. So what do you think that's going to mean in terms of the order of our console logs?
That's still a callback. So that still has to process it, but the 0 is a tricky question. I would think, just guessing here, will still be me first, but I don't know what 0 represents because it's no milliseconds. It's not.
Right. Carolina, you have really great intuition because you are still correct. We're going to go over why that is, but you were right because you said, wait a second. Set timeout is still a callback. There's still processing that needs to be done, right? Even though it says 0, there's still some work to do to then, you know, start calculating even how many milliseconds have gone on. So, Carolina, you are correct in that it will be the same. We will still see me first, and then we will see hello. And the reason is because, again, we're going to be JavaScript. I'm going into the details of this, but JavaScript is going to be passing off the print hello and the timer to another area to handle this information. We're going to leave JavaScript land to handle this information. And JavaScript is going to go, I'm moving on, man. I'm not sticking around for set timeout. I'm moving on to my next synchronous line of code, which is this console log. So this will still say me first, and then hello. And it'll be, pretty much immediate, because, we're not waiting 999 milliseconds anymore, right? There's no more code underneath this console log. So it's going to say me first, hello. But JavaScript moves on. When it sees a callback, when it sees functionality that deals with, asynchronous JavaScript, it passes that off to another area and continues its day. We're going to go on to the rules of how that works. But Carolina, well done and great intuition, because, you were correct. We're going to go me first and then hello. With that, let's go to questions. Let's go to Joanna.
Can you use an anonymous function as the first argument in set timeout?
You absolutely can. So Joanna's basically asking, well, what if instead of just, what if instead of print hello, what if we passed, a function that like this? Anonymous function just means a function with no name. We're just we're creating the function and passing that in within the line itself in this example. And you could definitely, these are basically the same things. So yeah, for sure.
Okay, thanks.
Okay. All right, Carolina.
Sorry, but in that example that you just deleted, yes, is an arrow function, but you're not giving any time. So how would
you still have the 0 here? So I would still put the the comma and then the 0.
Got it. I see.
Yeah.
Okay.
This piece here is going, into this first argument. Yeah. Cool. You could also, by the way, write this as, ES5. Arrow functions came around with ES6 as well, by the way. You could have also just written just like, function. And then, console log, blah, 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 print hello. But typically, you'll probably see usually a lot of functions that we're passing directly in line as an argument is usually an arrow function. But as far as the implications of arrow functions versus regular functions, we talk a little bit about that in object-oriented program hard parts, but you could do some research as to the differences between the two. But with that, we're going to keep moving forward here, because here's the deal. We need to start adding some more components to our board. I'm going to scroll down to our board again, and it's going to look a little different than the multiply by 2 example we had before, just a little bit. So don't panic, but a little bit different, because there's a couple pieces that are important to understand. JavaScript, as I said, is a single-threaded, language. It can only do one thing at a time. And that's limiting in some ways. And again, good, because we can track what JavaScript is doing. We know that JavaScript has our thread of execution, our memory/variable environment. Those are synonymous. We say memory, you can say variable environment, and the call stack, the kind of the main pieces. We need some new components here, because here's the deal. JavaScript needs, again, can only do one thing at a time, but it needs assistance. It needs help from something that can do more than one thing at a time. You know what can do more than one thing at a time? Your browser. Now, for those that may or may not know, the browser can only understand 3 languages: HTML, CSS, and JavaScript. The basic building blocks of websites. Those are the 3 languages: HTML, CSS, and JavaScript. Now, while your browser only understands those 3 languages, your browser was written in C++. The code that built Chrome or Firefox or whatever you're probably using was not written in JavaScript. It was written in a multi-threaded language, likely C++. So because of that, there's this nice synergy between our JavaScript environment and the browser's C++ multi-threaded environment. or what we're going to be doing, what JavaScript's doing, and whenever I say we, I mean JavaScript, by the way. I am JavaScript in this example. What we are doing is we are going to take our asynchronous work and we're going to hand it to our browser to work and do the rest of that computation, or the rest of that evaluation, the rest of that work. And we as JavaScript are going to move on with our day and check back later for whatever the work, whatever work the browser has done. And the place we're handing this off to, this asynchronous work, is known as the web browser API. API stands for Application Programming Interface. It's essentially kind of like the middle person between us and the browser itself, JavaScript and the browser itself. So you're going to see on the next slide, I'm going to have a location on the board called the web browser API. We're going to utilize promises. We're actually not using promises quite yet. We'll get there, but that'll come into play. We're also going to talk about the callback, also known as the task queue, but we're going to call it the callback queue tonight. And the microtask queue we'll talk about a little bit later, but for now, the callback queue, which I'll explain as we get there, but another piece to the board, and the event loop, which I'll explain on the next slide as well. Okay, let's do it. So just taking a look, we still have global memory, we still have our global execution context, we still have our call stack, but I've added our console, I've added the web browser API. This was a Google Chrome symbol that took me like embarrassingly too long to create in this app, but that's what that is. And then this is the callback queue, which we'll again talk about in a moment. But with that, I want us to go through this as kind of our first dive into asynchronous JavaScript and its various pieces. So Hank, could you do me a solid and kind of walk me through, starting on line 1, what you think's happening here?
Sure. So we declare a function definition with the label print hello, and that is going to be assigned the value of a function definition.
And where are we storing that? Beautiful. Should I use a different color? Maybe too dark. Okay, what happens next?
Then we move to line 4, where we invoke our set timeout. I guess, I don't know if you would technically call that a function or a method, what it's called, but.
Right, so good. It's a good question. Whenever you see parentheses next to just like a variable name, we always know that's a function, right? So set timeout is absolutely a function. You also say it's a method. It's a method on, not to get too deep, on our global function. We have a function called global, but this is a method. You could just call it a function. So we're invoking a function. And Hank, whenever we invoke a function, even if it's one we didn't create, if it's a built-in function, it's kind of follows the same processes as all the functions we've gone over so far. So walk me through kind of that setup.
That means that we're going to push a new stack frame onto our call stack of set timeout, and open a new, say it with me, everybody.
Okay, yeah, I'll do it with Hank. Everyone, for those that know you've been here before, Hank, I appreciate you so much for doing this. If you've been here before, unmute yourself, because you know what's coming. When we invoke a function, we create a new
Local
execution context.
Right, local execution context. Well said. For the newbies, know that that's a thing. That's like we do that all across our hard parts, and you just got to scream it out. Local execution context. Okay, so local execution context, we have our local memory. And this is for set timeout. Now, let me ask you first, Hank, what's the first thing we need to do whenever we invoke a function now that our thread has entered this local execution context?
We pair our arguments to our parameters.
Exactly. Now, we don't know what the parameters are because we didn't actually write this function, but typically, I would say, let's say the first parameter is like func for function, and we'll call the second parameter delay for how many milliseconds of the delay. So knowing that, what are we pairing?
So the func or callback that we're inserting as an argument, our first argument can be the function definition of print hello.
That's right.
And our second argument is going to be 1000 milliseconds.
Okay, excellent. Now, Hank, here's the deal. Set timeout is a asynchronous function. At least that's what it has, that type of asynchronous functionality under the hood. And remember, I said that JavaScript itself cannot handle asynchronous functionality. Where are we going to pass off this function and this delay, this information to? Taking a look at the board, where do you think we're going to move this data to? Let me ask you, do you remember?
So I'm hoping the name is a hint and that we're going to move it into our callback queue.
Not quite. I know it's a good guess. It's a good guess. Do you remember I said that JavaScript itself cannot really process asynchronous functionality, but it's got a friend that can. What is that called?
So we're going to move it into our web browser.
Exactly. Our web browser API. Exactly. So people, let me just go over what just happened here. Set timeout is invoked. It's a function. It has two arguments. The first one is the print hello function definition. The second one is the delay. But again, JavaScript can't handle this information. It's the web browser API that has things like time. JavaScript doesn't have a clock. JavaScript doesn't know how to count 1000 milliseconds, but your browser does, because your browser has connection to an internal clock that it utilizes that knows what milliseconds are and seconds are. JavaScript doesn't. So even little things like that, like what is time? JavaScript doesn't know. It needs help from someone who knows what time is. Your browser knows time. So we're going to offload, for example, our print hello function definition, the 1000 milliseconds, to the web browser API. But now, Hank, we're done. We're going to move forward, but we're done with our set timeout function. So, walk me through the cleanup here.
So we are going to, the toe is going to exit our local execution context.
Exactly.
Returning, as of right now, undefined to our global memory.
There's actually, because we didn't on line 4 even put a variable, like a place to save this. We're not even, there's no undefined even anywhere at this moment because we didn't put a variable. We just said invoke the function and we moved on.
So we exit our local execution context.
That's right.
Popping.
Yep. You got it.
Popping set timeout off of the call stack.
That's right. I'm actually going to just erase it just so it's very clear. Set timeout's gone. Okay. And like you said, we return back to global to what line?
So we move to line 5, where we console log me first, the string me first.
That's right. Now, people, from lines 4 to line 5, let's say 1 millisecond went by. So, Hank, how many more milliseconds do we need to chill here before the web browser API knows, handles the print hello when we move on to the next step?
Unless I'm really bad at math, 999.
No, you killed it, man. You killed it. Excellent job. Excellent job. So we're going to see here, like the JavaScript thread is just going to chill in the, for 999 more milliseconds. But at some point we will hit 1000 milliseconds. And this is the next part I want everyone to be aware of. We've hit 1000 milliseconds. Once that happens, the web browser API goes, I did my job. I, let this sit here, marinate in the web browser API, print hello, marinate in the web browser API for 1000 milliseconds. So now I'm going to take this function, the print hello function definition, and move it. Come on, man. Nope. And now you're messing up my Chrome symbol. Okay, let's try this again. And move it. Wow. You know what? And then you just get erased now. How's that feel? Okay, now move the print hello function definition to the callback queue. So I want everyone to understand what just happened. When your web browser API is done, you know, counting time or grabbing data, whatever, it's going to send back its, you know, that callback function to the callback queue. Okay. And now this is where our next vital piece comes into play. And we're going to talk about two vital rules with this piece. Because the next thing I want everyone to understand is the idea of the event loop. Okay. Now, the event loop is a process in JavaScript where there's basically literally it's called a process. And essentially it's a looping mechanism that's checking certain criteria. We're only going to focus on actually two of those today. We're going to start with the callback queue. And second, so I guess we'll talk about three of them today. The first two are the call stack and the callback queue. Okay. And essentially there are two rules that I need you to grasp when it comes to the callback queue and any of our kind of waiting queues and the call stack. Because we have I'm going to assume everyone feels comfortable knowing that we're going to move our print hello function definition from the callback queue onto the call stack and handle it, right? But how do we know that's going to happen? What are the rules? And here they are. First things first. The event loop is just checking our call stack and our callback queue and some other things, but those are the two things I want you to understand for now, the call stack and the callback queue. And it's asking itself these two rules. One, is the call stack empty besides global? Okay. Is the call stack empty besides global? Because if there are any other stack frames, any other work that's being done in some other execution context, if our threads, you know, in another execution context doing work, I don't want to suddenly jump out of that process or mess up that, you know, flow, handle our asynchronous code, and then not know where to come back to. So the first rule, our call stack must be empty before we push anything from the callback queue onto the call stack. So one, besides global. When I say empty, I mean besides global, okay? Second rule, is there any more synchronous code to run? Because if there's any more synchronous code to run, then JavaScript is not pushing the function, the callback queue, onto the call stack. So I'm going to say those two rules again. Is the call stack empty? And is there any more synchronous code left to run in our, you know, file? So Hank, knowing that, we just had 1,000 milliseconds. We brought our print hello function to the callback queue. The event loop is checking the call stack and the callback queue, and it's asking itself these two rules. And I want to ask the first rule, Hank, is our call stack empty?
I'm going to say no, because we have to push our console log onto the call stack.
Good question. Good point. So Hank is mentioning kind of the console log here. And and to your credit, Hank, while console log is a function, like technically JavaScript is going to push like a log function on and run that. For tonight's workshop, just to kind of avoid like handling the logs, because it's just, let's just assume we're not going to push and pop those off. We're just going to do it. So we already logged, we went to line 5, we logged me first. So we pushed log on, we logged me first, we pop log off. So you are correct. But now let's say we did that. So then again, now knowing that, is our call stack empty?
Yes.
It is, right? Because there's no stack frame other than global on there. And 2, looking at our code on the bottom left, is there any more synchronous code or code to run?
No.
So we pass the 2 conditions. Our call stack's empty. We have no more synchronous code to run. So we're going to bring our print hello function, push it onto the call stack. Or rather, the event loop will do that. Okay, so now, knowing that, Hank, we're about to invoke a function, right? We're going to invoke print hello. So people start getting familiar, warming up the vocals. We're invoking a function, which means we are creating a new
Local
execution
context.
Exactly. Exactly. So local memory. This is print hello. Our thread enters. And then, Hank, what happens in that?
Pair our arguments, which are none, to our parameters, which are none, and then we console log. And then we the toe exits the local execution context, and we pop print hello off the call stack.
Exactly correct. So this gets eligible for garbage collection. We pop print hello off the call stack. Our thread returns back to global, and then we've wrapped up our code. So Hank, excellent job. Way to walk us through our first asynchronous example. Really well done. Great technical communication. So people, this is, again, our first kind of our first step into asynchronous code. We're going to get a little more complicated from here, but I just want everyone to really, the thing to take away from this slide is that whenever we have asynchronous code, we're going to pass that off to our web browser API to do work for us. And we don't care. If I'm JavaScript, I care so little what the web browser API is going to do. I'm going to move on with my day. I'm going to keep doing my stuff. And while I'm doing my stuff, I'm moving on to lines of code. I'm running functions. I'm saving data. The event loop. I like to think of the event loop as like a kind of like a crazed wedding planner who's kind of like, are the flowers good? How's the catering doing? Like, are we on time with this? Right? Just like running around with a clipboard, checking the pieces it needs to check. And the pieces in this example are, is the call stack empty? Well, is there anything on the queue? Because if there's nothing on the callback queue, it's not going to do anything. But once a function hits the callback queue, it's checking the two things. Is the call stack empty? Is there any more code I need to run? Any more synchronous code left on the file to run? If those two conditions are met, meaning it is empty, there is no more code, then we're going to push that function from the callback queue onto the call stack. Okay, good stuff. I'm going to just take a look real quick. I haven't really checked the chat. I want to see if I missed any questions. I think I'm good. Yeah, I think I'm good. Okay, good stuff. All right, let's keep moving on. I don't see any questions, so we're going to keep moving on. All right, so yeah, here we go. We're going to start mixing now synchronous code and asynchronous code together and seeing what's happening here. And this should hopefully start to piece against some of those rules. Okay, so knowing that, let's go over to let's go over to Meredith. All right, Meredith. So
All right.
let's do this. Let's start on line 1. I know it's a little small. If you need me to make it bigger, of course I will, but let me know how it's looking. But otherwise, let's start on line 1 and kind of walk through what's happening here.
Okay, great. So we are declaring a function, print hello, and storing its function definition in global memory.
Lovely. Okay, what's happening next?
Next, we're declaring another function, block for 1 second. And I'm trying to read what's inside. Blocks in a JavaScript thread for 1 second. Yeah.
So exactly, just, we don't really care so much about exactly what it does. All we want to take away from block for 1 second is that whatever it does, it's synchronous and it blocks the thread for 1 full second, 1,000 milliseconds. So when we hit or invoke block for 1 second, we're stuck. The JavaScript thread is stuck there for 1 full second, okay?
Okay.
Okay, so block for 1 sec. Okay, where do we go next?
So next we're going to invoke set timeout with print hello and 0 passed in as arguments.
Lovely. So people, we are invoking a function, which means we're creating a new
Local execution
context.
lovely. Wow. Excellent, excellent job. I feel like we're harmonizing at this point. Okay, so we're going to invoke set timeout, create a new local execution context, and just put a little big local memory. And what other setup do I need to do, Meredith?
We're going to push set timeout onto the call stack.
Exactly. Okay, and again, so our thread enters this local execution context. What's the first thing we do whenever we enter a function?
We're going to pair our arguments and parameters.
Exactly. And again, we don't know exactly what the parameters are, but I'll just call it func and delay. And so what are the arguments?
So func is print hello, so the function definition of print hello.
Okay.
And then delay is 0.
Cool. Now, we know, Meredith, that JavaScript can't do asynchronous functionality itself. It's going to pass that information off. And where does it pass that information to?
It's going to pass it to the web browser API.
Lovely. Okay, so that's going to go off the web browser API. And in the time it's transitioning to the web browser API, we have some cleanup we need to do. What's happening with the cleanup?
So we'll pop set timeout off the call stack, and we'll make our execution context eligible for garbage collection.
Exactly. So that's gone. Our thread returns back to global. And what line of code does it go to next?
So next we'll go to line 7 and invoke block for 1 second.
Exactly. Now, people, keep in mind that the web browser API is counting. And it sees the 0, right? We pass 0 milliseconds as the delay. But Meredith, let me ask you, even in this moment, let's start with our first one. Is our call stack empty at this moment, right now? Is the call stack empty?
Yes.
Yes. Okay. All right. We got half of what we need. Let's look at the other question. Is there more code we need to run?
Yes, there's still code to run.
Exactly. We didn't get the 2 conditions, so we're moving forward. That's going to have to stick where it is. But Meredith, where does the web browser, the event loop, move the callback function now that it's counted the 0?
Now it'll move it to the callback queue.
Exactly. So you know what? It really doesn't want to move. So it's going to move to the callback queue, and I'm going to make it. But again, we got more stuff to do. We didn't, get our 2 conditions. So with that, we have to invoke block for 1 second. People, there's only so many of these. So I know, you can stay with me here. We're invoking a function, which means we're creating a new
local execution context.
Exactly. Great. So we create a new local execution context. It's got its own little local memory. What other setup do we need to do, Meredith?
We'll push block for 1 second onto the call stack.
Okay, awesome. And we know the thread enters this local execution context. Now, people, again, we don't know what block for 1 second is doing, but we do know that it blocks the thread for a full second. So the thread's just going to sit there, just sitting there. Okay. And during this, second, the thread is just hanging out. And in that time, the web browser API, even though it was 0 milliseconds, moved that information, that callback to the callback queue. But if it was 1,000 milliseconds, it would be counting. The web browser API can, again, handle all the functionality it needs to, regardless if the JavaScript thread is stuck. The JavaScript thread could be stuck for a second, but the browser's multi-threaded, ability is still doing its work. Now it, again, hit that 0 milliseconds. It moved the function definition of print hello to the callback queue, but our thread is, our call stack's not empty. There's going to be some more work we need to do. So let's say now, 1,000 milliseconds or 1 second has gone on, which means that Meredith, we're done with our block for 1 second. Local execution context. What do we need to do?
So we'll pop it off the call stack and make its execution context eligible for garbage collection.
Exactly. Which means our thread returns to global. And okay, well, let's take a second here. Meredith, is our call stack empty?
It is.
Now, Meredith, is there more code we need to run?
Yep, there's still code to run.
Exactly. So that print hello callback still has to sit there. That's just the rules of the game, people. So what's going to happen next, Meredith?
So next we're going to log me first to the console.
Awesome. Okay. Then what happens?
And so then our event loop is going to check to see if there's anything in the callback queue, and it's going to check our call stack. There's nothing in the call stack except for the global call frame. And it'll then check to see if there's any more synchronous code to run, and there isn't. So it'll put the function print hello onto the call stack, or it'll push it onto the call stack.
There you go. I was gonna you amazing. Well, way to catch yourself. It's gonna push print hello onto the call stack. So let's do it. Let's push print hello onto the call stack. And people, we're invoking a function, which means we are creating a new
local execution
context.
Exactly. The thread enters. And what does this function do, Meredith?
It logs the string hello to the console.
Okay, what happens next?
Next, we'll pop print hello off the call stack and make its execution context eligible for garbage collection.
Excellent. Which means it's empty. This is gone. Our thread returns back to global. And then we are done. Meredith, excellent work. Way to take on that challenge. Again, really solid technical communication. Amazing work tonight, everyone. Seriously, really, you should all be very proud of yourselves. Excellent job. So the thing I want you all to take away from this example are kind of similarly from the last slide, our last kind of draw through here. We have to follow these rules. It doesn't matter if it's 0 milliseconds. It doesn't matter if it's 1,000 milliseconds. When we hit some asynchronous code, we pass that code off to the web browser API, and we're going, once the function, any function in the callback queue, the event loop is checking 2 rules. Is the call stack empty? Is there any more synchronous code to run? Until those 2 conditions have been met, the callback queue stays, the callback function stays in the callback queue. So this leads me to my next point, which is this. We put on line 6, set timeout, print hello for 0 milliseconds, but it actually took about 1,001 milliseconds before we saw hello. This is my next point, which I want you to understand from coding in JavaScript. It is, when you are working with asynchronous functions, it is pretty much impossible to know the exact moment that your code's going to come back. We might put 1,000 milliseconds. That does not mean it will come back exactly in 1,000 milliseconds, right? It'll come back when 1,000 milliseconds has eclipsed. If we put 1,000, I know we put 0 here, but if we put 1,000, it'll come back when after at least 1,000 milliseconds. We know it'll be at least 1,000 milliseconds, but until those 2 conditions are met, we're not bringing anything from the callback queue into the call stack. So there is an element of unpredictability when it comes to asynchronous JavaScript. We don't know the exact moment when we're going to get information back, but we can write logic that says, well, whenever we get it back, here's what I want you to do with it. And we're going to talk more about how we write that logic a little bit later on when we, maybe the next slide when we talk about promises. But just know that when you're coding with asynchronous, using asynchronous JavaScript, the trade-off of being able to do asynchronous JavaScript and pass this off to the web browser API is that we don't actually know the exact moment we're going to get that information back. And that's okay. We don't necessarily need to. We just need to set up logic that says when it comes back, here's what I want you to do. And we'll talk about that on the next slide. Let's go to Luis.
Oh, so is the time bound only run after the two conditions have been met? Is that
no? The time is going immediately.
Okay.
But it's only the function's only coming back to the callback queue or the call stack. Apologies. The function's only moving from the callback queue to the call stack once the two conditions have been met.
Okay. All right.
So it might so Luis, to your point, the relationship between the web browser API and the callback queue is exact. If we put 0, it'll go directly from the web browser API to the callback queue. If we put 1,000, it'll go directly from the web browser API after 1,000 milliseconds to the callback queue. But the relationship between the callback queue and the call stack is not exact because we have to hit those two conditions.
I see. Okay. Thanks.
Yep. Hank?
So if we're doing something like actually like how inside of print hello, which we invoke inside of our set timeout console log.
Yep.
Obviously, like if I can see how you would use a console log in like Chrome and it would be run through the browser first. But if you're like console logging to like Node or like a built-in terminal in your like VS Code or something, is all of that like simulating what's going on, or is it like reading the browser somehow?
Hank, it's a really good question. And I think what your question boils down to in essence is JavaScript is a full stack language, which means it works with the browser on the front end, but the back end JavaScript environment is called Node. And that's what Hank was mentioning with Node. But your back end doesn't have access to the browser, right? Your front end is working with your browser. So what's your back end working with? And Hank, exactly correct. It is basically simulating that type of environment. It has a library called libuv built into it in the backend in Node, and it can simulate what's happening on the front end. So it's basically, it does a little differently, but at the end of the day, it's the same in practice. Yeah.
Thank you.
Yeah, sure. Okay. All right, let's keep moving on. We have a couple more examples to get through. So some problems. Our response is only available in the callback function. This can lead to what's called callback hell. Callback hell is not on this slide itself, but you can Google callback hell. You'll see a picture. It looks like this like nested functionality. Essentially, it's just harder to read as a developer. Callbacks, if you have a bunch of callbacks, get this information back from this function, asynchronous, this asynchronous function. When you get that function back, for example, I want you to go get tweets. When you get the tweets, I want you to take those tweets and then go get users. And then when you get the users, I want you to take those users and then go get their profile pictures. When you get the profile pictures, I want you to go then get their tweets, right? And so there's this asynchronous functionality that if you code this, it looks you may have seen it before. It's kind of like this, like almost like stepping looking code. That's called callback hell. It's just really hard to read. In addition, maybe for some people, it feels a little bit weird to pass a function into another function. I guess that could be a possibility. If you work with JavaScript, not all languages can you pass functions into functions, but JavaScript you can. So if you work with JavaScript, that's actually very normal. The good thing is, again, hopefully you understand how this is maybe working under the hood. But here's the thing. JavaScript, ECMAScript, again, 2015 came around, they said, what if we could make asynchronous JavaScript just a little bit more readable and maybe add in just an extra little benefit, which I'll talk about in a second. And they came out with promises. What we were just working with was an example of a callback. Typically, you're not going to use set timeout, to handle like getting tweet information. You're going to write a function and you can look up how you can handle that. But you can also use promises. Now, how do promises work? Let's take a look firstly at this code snippet here. Actually, I think I have it here. Good. So let's say we have a function called display, which we're going to console log our data. And then the line after that, we have this variable future data. We're assigning it fetch. We're invoking a fetch function, passing in a URL. Now, the fetch function is a built-in asynchronous function on the front end when we're working with the browser. And essentially, it's just a way for us to make requests from our browser to, a server for information. So basically, we're saying here is, hey, Reid's Google Chrome, I'd like you to go make a request to twitter.com/tweet/1, which is a literal specific, location on a server, basically, and get data, get the tweet, the first tweet. Okay. Then here's the cool thing. Remember I said we want some function, we have some good clear code of what we want to do. We don't know when we're going to get that information back. Maybe Twitter's servers are slow. It's getting bombarded. I don't know, whatever the reasons are, okay? So maybe it takes half a second. But all we want to write is, well, whenever we get that information back, then invoke display. So whenever we get the information back, then invoke display. What does display do? It'll console log data, which will be this, tweet. So now what does this mean? There's a bigger piece here going on, which is promises. Okay. The first thing I want you to take away was the then. We know that whenever we get information back, then invoke display. Fetch. Fetch is an asynchronous function that returns a promise. Now, what is a promise? A promise, really put simply, is just an object. It's just an object, okay? But it's an object that essentially will act as a little bit of a placeholder. So whenever we invoke fetch, it immediately returns a promise object. So remember earlier when we invoked functions, it was undefined until we got data back? That's different when we're working with promises. When we invoke a function that deals with promises, it immediately returns an object. We're going to fill in that object with information when we get that information back, but future data is not undefined until we get data back. It's an promise object until we get data back, okay? This promise object has 3 key properties we're going to talk about. There's a lot more than that, but we're going to talk about 3 of them tonight, okay? The first one is the value. Now, this is undefined. The value is the information we're going to get back. We haven't gotten it yet. So until we get the information back, the value property in this object is undefined. The next property is the status. Now, a promise object can have one of 3 statuses, okay? Pending, fulfilled, or rejected. Now, my little analogy for a status on a promise object is like your dishwasher. Your dishwasher can live in kind of 3 states once you've told it to run. Once you've kind of, put the dish soap in, or maybe not, once you've told your dishwasher to run. The pending status is it's working, it's doing the work. It's trying to, clean the dishes. But once it's done cleaning the dishes, it has either fulfilled, meaning the dishes are clean, it's what you expected, it's what you wanted your dishwasher to do, or it's rejected, meaning something went wrong. Maybe you forgot to add the soap or something, maybe there was a mechanical issue with your dishwasher. It's the same idea with your promise object. When we're, while fetch is doing its work and talking with the web browser API, which is then talking to Twitter servers, we're going to be in a status of pending, right? We're waiting for information back. But once we get information back, if it worked out, if things went correctly, then the status will change to fulfilled. Fulfilled. If something went wrong, it would change to rejected. Now, for tonight's workshop, we're not going to deal with what happens when things get rejected. If you have questions about it, we can talk about it after the workshop. But we're just going to pretend everything works out well. Okay, you can write certain logic for if things go wrong, but we're going to, for tonight's workshop, everything went right. So the last piece is a key called onFulfilled, which is essentially what function do you want to run when the status changes to fulfilled? So if we look to the left here, we see this then function, and it's saying, hey, when we get this, when the status of this promise object goes from pending to fulfilled, and we get a value back, like, maybe we get back the tweet, hello. Maybe that's the value that got back. The status changes to fulfilled. Well, we know what we want to happen then is to invoke the display function. So on fulfilled, invoke the display function. I know this is a lot. Hopefully you'll get more comfortable as we go through this, but let's do it. Here we go. There's another piece here. You may have seen the microtask queue came into play. I'll talk about that when we get there, but let's go through this coding example, and let's go with Robin. Robin G.
Hey.
Hey. All right, Robin. Good to see you again as well. So Robin, let's start on line 1 and go from there.
Yeah, we'll define a function definition called display.
Okay.
And then we'll go in the global memory.
Nice. Okay, where we go next?
And we'll go to line 4, and we will define a constant variable called future data.
Right, in global memory.
In global memory, that is going to be equal to a fetch.
Yeah, nice. We also typically, just so everyone knows, we typically call this a fetch request. You could say invoking the fetch function. We say a fetch request. Now we're invoking a function, so things are like how we always invoke a function. But Robin, remember, fetch is a asynchronous method or asynchronous function in JavaScript that will always return what immediately?
It will always return an object.
Nice.
Immediately with a null value. I believe it's null or empty.
You can say null. Yeah. Okay. So we'll get to, actually, let's do that. There are 3 properties we need in this object. What is the first one?
The value.
And we'll set it to undefined for now. Then what's the second one?
I know we just looked at this, but is the second one status?
Exactly.
Okay.
Correct. And what is its status now that we're about to go do some work?
I'm not sure. I'd say it's pending.
Yes, you are exactly correct. And then what's the third key we want to have here?
I believe that was results or something along those lines.
Really close. On fulfilled.
On fulfilled, yeah.
But that's the same idea. Like once we get our results, then do something. Okay, so that's what our future data variable looks like in global memory at the moment. We are invoking fetch, which means we're invoking a function, which when we invoke a function, that means we are creating a new
local
execution context.
Exactly. So let's open up a new local execution context with its own little local memory. And Robin, what do we have to do with the call stack?
We have to go ahead and push our fetch request on there.
Exactly, which means our thread moves into our now. People, again, we didn't write the fetch request. That's built in, so we don't know what the parameter is. But let's just call the parameter like URL.
Okay.
So, Robin, what's the argument then?
The argument would be HTTPS twitter.com will tweets 1.
Exactly. So I'm just going to write just like Twitter.
Cool.
For my own sanity. Now, Robin, fetch is asynchronous, and JavaScript can't do that. It's going to need to pass this information off somewhere. Where is it going to pass this URL to?
It will go to the web browser API.
Exactly. Okay, you know what? Maybe it's me at this point. I'm starting to think it's maybe me. Okay, so Twitter is going to pass off here. And it's really the full URL, but we're going to kind of shorten it. And the web browser API is going to, through the internet, connect to Twitter servers and go grab its information. It's going to do its thing. Okay, but we're done with our local execution context, Robin. So walk me through the cleanup here.
So the local execution context is eligible for garbage collection.
Yep.
And we can go ahead and pop the fetch request off the call stack.
Lovely.
And we're going to enter the thread of execution back into the global thread of execution.
Exactly, global space. And so
Global space.
we're on line 5. And if you want to take a guess, so we are invoking a function on line 5, right? What's the name of that function, Robin?
I believe that name of that function is dot. Well, it's then.
It's then, exactly. It's then. But like kind of console log, I'm not going to do the full setup and everything. Just know we do invoke a function. We do push it onto the call stack and pop it off. But what I want you to take away from line 5 is we have an argument inside of the then function. What's that argument on line 5, Robin?
Display.
Okay, so display is a function, right? We have that in our global memory. It's a function definition. Oh, my computer just went dark mode on me. Okay, so once we have our then, we're going to pass that display function definition somewhere, which basically says, hey, if things go well, I want you to invoke display. Where are we going to put that display function definition?
I believe it's going to go in the web browser API again.
It's a good guess. It's a good guess. Because again, usually when we say we're moving things or passing things, we're going to the web browser API. But in this case, we're actually not going to the web browser API. We're going to take the display function definition and we're going to assign it to a key, to a specific key that says, hey, if things go correctly, I want you to then run display. So taking a look at the screen here, where do you think we could put display? What key could use a display function definition value?
On fulfilled. So yeah, once it's fulfilled, it'll run display. Okay, inside our future data fetch request.
Exactly, inside of that promise object. Exactly correct. So that's what the then does. It takes whatever function we pass in and moves it to the whatever it's thenning, it's on fulfilled property. So the then is on future data, so it's moving display onto the onFulfilled property on the future data promise object. Okay. So let's just say, Robin, hypothetically, that in the time it took to, I mean, it probably wouldn't, but let's just say hypothetically, in the time it took to bring the onFulfilled or the display function definition to onFulfilled, let's say in that time, we got the tweet back.
Mm-hmm.
We got the tweet back. Okay.
We would.
And let's say it was the string hello. We'll stick with hello. Actually, wait. Yeah, we have me first. Let's see the string hello. Now, people, I know we see 2 queues here. I'm going to explain this in a second, but hello is actually not going to go to the callback queue. It's going to go to the microtask queue. Oh, no, I'm so sorry. I said that totally wrong. I apologize. Let's back this up. Let's go to line 6, and then we'll go back. So apologies. Let's go to line 6. What's happening on line 6?
We're going to log me first to the console.
Exactly. Apologies. So we get me first. Okay, awesome. Now, let's say the time has gone by. We have wrapped up and gotten our value back. It's the string hello. Robin, looking at our screen here,
mm-hmm.
We finally got some data back. Where are we going to take the string hello to? Where are we going to move it to? What is now going to be the value of hello?
We'll store that in the key of value of future data.
Exactly. Okay, so now we got the data back, but we're not done, right? So Robin, what else, now that we've got this data back, what else needs to change in the future data promise object?
The status key would now change to complete.
Close. it technically is, it's fulfilled, the same idea.
Fulfilled, okay.
But the value is fulfilled.
Okay.
And now that the status is fulfilled, we have some work to do. We need to take whatever function is supposed to be called onFulfilled. We need to move it to the microtask queue. Why the microtask queue versus the callback queue? I will explain on our next example. But just understand that when we're talking about promises versus callbacks, when we're talking about promises, we move data to the microtask queue, different than the callback queue. So Robin, we're going to move which function definition to the microtask queue?
Display.
Exactly.
Quick question on this. We don't pass an argument in display up to, at the then function. Is it just assumed that the value of future data gets tied to that and passed up the display?
You'll see. We'll get there in a second. Exactly.
Okay.
So even though the microtask queue is called the microtask queue versus callback queue, it still actually has to follow the same two rules. So Robin, let me ask you, is the call stack empty?
The call stack is empty.
Is there any more code we have to run?
No more code, no more synchronous code to run.
Sweet. So because of that, we've passed our two conditions. We exit the function, exits the microtask queue, gets pushed onto the call stack. And people, we are invoking a function, which means we are creating a new
Local execution context.
Lovely, exactly correct. So this is the local memory for display, which means our thread enters. Now, here's the question, Robin, you kind of asked, which is, what's the first thing we always do when we enter, finally entered a function, a local execution context?
We'll pair the parameters with the arguments.
Exactly. So let's start with what's the parameter?
Parameter is data.
Exactly, right? Because we see looking at display, we got our data parameter. So we know there's going to be at least data. But what's the argument? And now here, people, is the next important piece to understand about promises. JavaScript will automatically, for you, pass whatever the value it returned, in that initial promise, will pass as the argument into the onFulfilled function. Does it automatically for you? You don't have to worry about it. It will automatically say whatever value I get back will pass as the argument into my onFulfilled function. So knowing that, Robin, what's the argument?
That is the value key of future data, or the value of the value key of future data.
Right, which is what?
Hello, the string hello.
Exactly.
Yeah.
And then what does it do?
It will log hello to the console.
Exactly. Okay, we've now wrapped up this execution context, Robin. So what do we need to do?
It's eligible for garbage collection. And we can pop display off the call stack. And we'll enter the thread of execution back into the global space.
Exactly. Okay. Robin, excellent work. Seriously, great communication. Again, this is very complex stuff. I know we just took a pretty big leap here. So really, really well done. Let's do some questions. I will say, I think the next slide is going to answer a lot of questions, but let's get to them anyways. Let's go with Carolina.
I think I'm confused. I don't even know what I'm gonna ask, but so on line 5, then you said then is a function.
Yes.
Okay. So it's invoking another function. But that function is not being invoked. Like I'm confused with confused with 5. I don't know if you can.
So what's the question? Just like what's happening on line 5?
Yeah. Sorry, I'm just trying to figure out what's going on.
Sure, no worries. It's a good question. Let's take a look at line 5. So in line 5, we're saying we want, because by the way, anytime you see parentheses next to just like a label, you know it's a function. It may not be a function you wrote, but it's a function. That's what in JavaScript in most languages calling a function, something with these parentheses. Okay. So we're saying, okay, future data we know is a promise object because fetch always returns a promise object every time. That's what fetch does. Immediately returns a promise object. And this promise object is what's called, it's a thenable object, a thenable object. What does that mean? It means you can invoke the then function on it. It has a built-in function called then. And then that's a thing. You can look up thenable objects that have a built-in then. It has to do with, again, asynchronous JavaScript. And what the then function does is it says, hey, when future data's, it says, I want to pass to future data's onFulfilled key the value of the display function definition. So the then says, go to the future data. Is this at this point, right? Let's go back to what it looked like. Okay, so once we get, it's going to say, I want the onFulfilled property to be the display function definition. That's what line 5 is doing. Set the onFulfilled property of future data to display. What does that mean? Well, when the status changes from pending to fulfilled, which means we got, a value back again, like, maybe the string hello, then move display's function definition to the microtask queue. And then follow the same logic. Is the call stack empty? Is there more code we need to run? So again, if I know this is confusing, it's a lot, but all you need to know is on line 5, we're saying set the onFulfilled property on future data to the display function definition, so that when the status changes to fulfilled, move display to the microtask queue. Okay. Again, I know a lot. And again, once you go through this again a couple more times, hopefully it'll start to click a little bit more, but this is really hard stuff. So it's really abstract. Cool. Okay. Let's go to Meredith and then Michelle.
So my question is about callbacks in general, but line 5 really brought up the question in my head for me. So when you create the promise object and it stores in onFulfilled the function definition, I'm curious, does it store the label as a pointer back to the original place that you stored your function in global memory, or does it actually make a copy of the function definition kind of as it moves around here?
Yeah. So Meredith is asking a good question about memory. This is basically how does memory work in referencing data in memory. And functions and objects and arrays are what are called composite data types. Functions are actually just kind of honestly objects. You can learn more about that in our object-oriented programming workshop, but functions are objects. And objects and arrays, arrays are objects too, actually. But basically, arrays and objects are composite data types. And composite data types are when you're referencing information in memory. So when you're referencing an array in memory, an object in memory, it's what's called pass by reference. And pass by reference means when we say display, on line 5, it's so, if we look at global memory, we see 2 displays here, right? We see the display here, we see the display here. So you might be thinking, wait, are there 2 display functions? But Meredith, to your point, this display label is just referencing the same function in memory. We're just pointing to the same function memory. So for example, if for some reason we wanted to, mess with this display function, if on, later on we wrote logic that interfered with display, would change it everywhere display is referenced in our code. That's how objects and arrays work. If we're not making copies, which is why you need to be really careful with how you manipulate your objects and arrays, because anywhere you manipulate, if you're passing an array around your code or an object around your, code at different functions, it's the same object you're passing. If you're, let's say we have an object called obj, and you have a function that adds a property, and then the next function looks for a property and adds two, and then another function takes a property and, its value, removes its value. Everywhere that object is referenced, that manipulation has occurred. So meaning, like, if we go back and console log our object now, it's going to have a new property or deleted other property. We're not making copies. So if you want to make copies, which is a good thing to do, to think about, you have to write logic, but that's not what we're doing here. We are just referencing the same function definition in memory. Good question. Awesome. Let's go over to Michelle.
Yes, I was going to ask you if do you ever combine the microtask queue with the callback queue at all?
So we'll wait till the next slide or the next example to go through it, but we don't combine them. They are two separate queues that have one has a benefit over the other, but we'll talk about that in the next example.
Okay, but the microtask queue always takes precedence over the callback queue, right?
It sounds like this ain't your first rodeo, Michelle. So you're exactly correct. We'll get to that in a second, but that is the slight difference over the microtask queue. But let's get everyone else caught up, and then we'll get there.
Gotcha.
Awesome. All right, let's go over to Joanna.
Yeah, can a fetch request return multiple values? And if so, how does it store it on the value property in the object that's created by fetch?
Right. It can't return multiple values, but you could return like an array of values. Right? You could have like the string hello, and then the string, bye, and then the string, what up.
So like if it were returning multiple tweets, would it store them on an array on that?
Yeah, probably. It would probably be stored in an array, and then you'd have to have some logic in display, because now data is not the string hello. Data is an array of strings, right? So you need to probably have some type of like a for loop, or, data dot for each, you call some function, and then you have some logic that's going to iterate through your data array and do, some logic there.
Okay, and then if the unfulfilled function, like if it only takes one argument, is it just going to ignore the others? Like if it wasn't set up to take or to deal with an array, it would just use the first element, or?
No, I mean, whatever is in value is getting passed as the argument in display. So if you don't have logic that handles that appropriately in display, then it's not going to, if you wrote console log, so if we look at line 2, which says console log data, now data is an array of strings, right? So you'd get to the console, instead of hello, you'd have, an array of strings in the console. So you need to write logic in your display function now that says, hey, instead of console log data, iterate through our data array and console log each element. And then you would get, hello, bye, what up, etc. You need to write the logic that's appropriate to the type of data you're receiving back from your fetch request or your promise.
Gotcha. Okay, makes sense. Thanks.
Yeah. Cool. Okay, let's go to Hank, and then we're gonna move on to the next example, which might be the last one, I believe.
Yeah, and these are just two quick questions. The JavaScript itself is read by the what? Like because we're always talking about like the thread of execution is going here and there and all, like, is it the browser? Is it like your computer? Like, what is doing all of this?
Sure. So on the front end, Google Chrome has a engine called the V8 engine, and it's an engine that is a runtime for your JavaScript code. And a runtime is just again like a place in an environment, which is really kind of, if you think about it, like a selected. This is an environment, a process that's occurring on your browser that essentially is using your thread and going line by line and running that code. There's kind of two phases to your code when you say run. There's compile time and run time. Not to get too complicated, but essentially compile time is like your browser's engine, the V8 engine is going to do like an initial scan of your code just to make sure like there's no syntax errors, kind of the basics. Then it's going to run it, and that's called runtime. And it's an environment that, with the thread, kind of what we're doing here, runs that code. So you could think of what we're doing here as the browser running the V8 engine during runtime. Is what we're doing here.
And then the other thing I want to ask is that on line 5, why are we passing in display but not with parentheses? Like, is it built into how then works that it'll invoke the function passed in?
Hank, this is a good question. This is a good setup. So Hank's asking, why are we not passing in display parentheses, right? I got to make this smaller when we get down to this size. Okay, why aren't we passing in display, with two parentheses, parentheses like when we're invoking a function. So Hank, JavaScript is going to read every single piece of code we write. And it's going to see the future data, then it's going to see display inside of these parentheses. And what it's going to see is a parentheses next to display. Hank, what do parentheses next to a keyword tell JavaScript?
Look for this variable, or look for
kind of, yeah. Yeah, it's gonna say, okay, so it's gonna say, look for this variable. What's the variable?
Display.
Okay, is there a display in memory?
Yes.
Sure is. And what does then it do? Because that's what parentheses tell JavaScript to do.
Well, the parentheses would invoke the function definition.
Yep, right then and there. So if we put a parentheses on line 5, we're telling JavaScript, I want you to pass as an argument into then whatever gets returned from invoking display right now.
Oh, I see.
Right. So we'd invoke display and we'd probably get an error because there is no data. So you'd console log like undefined because, we wouldn't get an error. We would just console log undefined. So if we invoke display on line 5, we'd be passing into then undefined because that's what would be get returned from invoking display at that moment. Instead, we want to pass in the function definition because JavaScript knows that, hey, if I get a function definition, I'll invoke it for you. I'll take that function definition and invoke it for you and pass in the argument for you. If you put parentheses on line 5, you're telling me pass into then whatever gets returned from invoking display at that moment. Cool? Okay.
Yes, that was perfect. Thank you.
Yeah, of course. Excellent question. Excellent question. Okay, people, let's move on to, I think, what is our last example? And it's a big one. It's a lot we're working with here, but this should put everything together. So with that, let's go to Catherine. Whenever you're ready. I know you're taking some notes, which is great. But if you're ready, let's go to line 1. Let's walk through what's happening here. Good technical communication.
Okay, so we're declaring a function display in global memory and storing the function definition in global memory.
Excellent. Let's move this back up to 3. Okay, what happens next?
So since it's still on, even though it's on one line, we still wouldn't go into the function, right? So you would still go
exactly
onto, okay. So on the second line, we're declaring a function print hello and storing it in global memory.
Okay, keep it going.
And then declaring a function block for 300 milliseconds and also storing it in global memory. Was it still be just storing the function definition even though there's not anything in the code block?
Yeah, it would. I mean, there
Okay.
would, I mean, you know, in
Which I think
theory,
you would
there
be.
is something
Okay.
in there. We're just not writing it, and whatever that is
Okay.
blocks the thread for it. But yeah, it would.
Okay, cool.
Okay,
And
excellent. What line do we go to next?
Okay, then we go to line 5
Mhm.
and declare function set timeout. Well,
Are we
we're
declaring set
invoking the function. Okay, so we're
We're
invoking set
invoking set
timeout.
timeout. And so we're invoking a function, people, which means we only have like a couple more of these. So we're at the near end here. We're invoking a function, which we're creating a new
Execution context.
Execution context.
Exactly. Okay. So let's use this color and let's set it up. This will be our thread enters. What do we need to do with the call stack, Catherine?
Okay, so we're pushing set timeout onto the call stack.
Yeah. Excellent. Okay. Again, Catherine, we don't know what the parameters are, but we're just going to go with, you know, func and delay. So what are the arguments?
The print hello function definition.
That's right.
And then 0 for the delay.
Okay, excellent. Now, Catherine, we know that JavaScript can't handle this asynchronous functionality. It needs a friend to do that. So where is JavaScript going to pass this information to?
To the web browser API.
Exactly. You know, I feel like they updated this app like really recently and it's messing with me. So we have 0, we have print hello. I'll actually just write, I'll put the full function definition. Okay, cool. But we're done with set timeout, so we have some cleanup to do.
Okay, so the local execution context gets garbage collected, and then we pop set timeout off of the call stack.
Exactly. Okay, what line of code do we go to next?
Line 6.
Okay, and what's happening on line 6?
So we're declaring a constant variable future data and assigning it the fetch function or the result of calling the fetch function.
Exactly. And we know, Catherine, that fetch is a function that deals with promises, right? So what is future data? What does fetch immediately return?
An object.
Right.
Well,
and what type of object? Exactly.
Promise object.
Okay. And there are some keys that we need to go through. So what are the keys?
Value, which would be undefined to start. And then the status, which would be pending. And then whatever we want, the unfulfilled, whatever we want to happen.
Exactly. We'll get to finishing that up in a second. But exactly. So we are invoking a function, right, people? Because we're invoking fetch, which means we are creating a new
local execution
context.
Wonderful. So let's open that up. And Catherine, what do we have to do with the setup on the call stack?
We have to push future data onto the call stack. Or sorry, fetch onto the call stack.
Exactly. Which means there are thread enters. And again, we don't exactly know what the parameter is, but let's just say it's URL. And what's its value?
The URL on there, like HTTPS, like Twitter.
Exactly. So we'll just call it Twitter.
Okay.
Now, let's say in this time, Catherine, while that's all happening, the web browser API is counted, it's hit 0 and no 0 happened. Take a guess, we have 2 queues here. Where do you think the print hello function definition is going to move to from the web browser API? It's going to move to one of these queues. Take a guess, which one do you think it is?
Microtask queue?
You had a 50-50 shot. And sadly, it did not go your way on this one, but it's a great guess. It's a great guess because keep in mind, people, that set timeout deals with callbacks, purely callbacks, whereas fetch deals with promises, right? So we're going to move our print hello function definition into the callback queue. Okay, because set timeout deals with purely callbacks. Promises deal with the microtask queue. Callbacks with the callback queue. Okay. So knowing that, let's go back to fetch. We know that JavaScript can't handle making like requests to servers. That's something someone else does, something else does. Where are we going to move this URL information to?
Into the web browser API.
Exactly. Okay. Now we have wrapped up fetch, that function itself. You know, our web browser API is communicating with Twitter servers. It's doing its thing. What's the cleanup we need to do now?
So we're gonna pop fetch off of the call stack, and then the local execution context gets garbage collected.
Exactly. Okay. So we're back in global. Now, let me ask you, Catherine, we have this function sitting in the callback queue, the event loops checking the call stack to the callback queue. Can you walk me through, do you remember what are the 2 things that the event loop's checking to see if we can take this print hello function from the callback queue onto the call stack?
Okay, so it checks if the call stack is empty, which it is besides global right now.
Okay, lovely.
But it also has to check if there's any other synchronous code to be run, which there is.
Exactly. So we got to keep moving on. Exactly. So what line are we on next?
Line 7.
Okay, walk me through that line.
So we are invoking the then function on future data.
We are exactly correct. Now we're not going to open up the execution context and all that stuff, but that is really what does happen under the hood. But what does the then function do for us?
You know, we've gone through it, but I already forgot.
It's all good, all good. Take a look. Take a look at our future data, and what do you think we want to maybe change inside of our future data or update inside of our future data object?
Is it changing the unfulfilled, like it's putting display in that spot?
Exactly. That's what the then function does. It sets the value for the unfulfilled property in the data in the object it's thenning.
Okay.
Right. So great. We go to the next line. What's happening there?
Okay, then we're invoking the block for 300 milliseconds function.
Okay. Lovely, people. We're invoking a function. I think there's only 2 more of these. We're invoking a function, so we're creating a new
local execution
context.
Okay, so let's do it. I think it's this one, maybe. Okay, let's set that up. What's the setup on the call stack?
We are pushing block for 300 milliseconds onto the call stack.
Exactly. Which means our thread. Okay. Now, again, we don't know what block for 300 milliseconds does, but it's going to block our thread. Our thread's going to stay there for 300 milliseconds. Let's say, Catherine, in that time, we get the information back from Twitter servers. We have that tweet. That tweet is this tweet hello. What do we need to update?
The value key in the future data object.
Exactly. So that's now actually instead of hello, because we have a print hello function, let's say the tweet we get back is async rocks. Okay. So the value is async rocks. Okay. So we just got a value back, Catherine. So there's some other things we need to update in this object. What else?
So the value, it gets connected to the display function on the
We'll get there.
right?
We'll get there.
Oh,
But before we can even handle the display function, you know, we know that the display function should be run when what happens?
When it's fulfilled, so the status should be fulfilled.
Exactly. We need to change the
Okay.
status. And now that it's fulfilled, we know that we want to work with this display function, but we don't get them's the rules. We don't get to just take display and run. We got to move display somewhere. Where are we going to move this display function definition to?
Into the microtask queue.
Exactly. Right? Because this is a promise. It goes in the microtask queue. So let's do that. Okay, great. Now 300 milliseconds has gone by. We are wrapping up block for 300 milliseconds. What's the cleanup on block for 300 milliseconds?
Okay, so we'll garbage collect the local execution context and pop it off the call stack.
Exactly. Okay, people. Now we're going to check our two rules. Catherine, walk me through them.
Okay, so first the call stack is empty except for the global, but we still have synchronous code to run, so we can't.
Exactly. So what's that code?
On line 9, then we'll console log me first.
Wonderful. Okay. Now, Catherine, we have now going to do our double check or two checks, which is the call stack empty size global? Yes. Is there any more synchronous code? No. Okay, so we have met our two conditions. Now, Michelle talked about this earlier, and this is a great setup. I'm going to ask you, Catherine. Right now, we have a function definition sitting in the microtask queue and a function definition sitting in the callback queue. So how does JavaScript, and you take a guess, how does JavaScript decide which function to run next? It's got two options. What do you think it does to maybe decide which one to go with?
I think it prioritizes the microtask queue, but I don't necessarily know why.
It's a good question. And the answer is because that's how JavaScript developers wrote it. That's the rule.
Gotcha.
The rule is so the microtask queue and the callback queue both have to follow those same two rules. Is the call stack empty besides global, and is there any more code to run? But the callback queue has an additional rule, which is the microtask queue empty? The microtask queue will always get priority over the callback queue. So if you know our print hello function definition has been sitting in this callback queue for like half a second at this point. Our display function definition just got to the microtask queue. It doesn't matter. If there's a function definition sitting in both queues, the microtask queue gets priority. Just the rules of the game. So Catherine, what function are we invoking?
We are invoking the fetch function.
Right,
Wait,
exactly.
yeah.
Well, what's the function that we got, that we know we want to run on fulfilled?
The display function.
Exactly. So people, this is legit the actual second to last one. So what we are invoking function, which means we're creating a new
local
execution context.
Right. Okay. So what is the setup on the call stack?
So we're going to push display onto the call stack.
Excellent. Change our thread, enters. And what are we going to do next, Catherine?
Console log data.
Well, yes,
Or
but we need to, whenever we enter a function, the first thing we need to do.
pair our arguments with our parameters.
Exactly. So what is our parameter?
Data.
And what is our argument?
Is it just what you're getting from future data?
Yep, which is what?
The object, the whole object?
Not quite. Do you remember what within the object do we pass to display? Not the whole
Just
object.
the async rules. Or
Exactly.
rocks,
Whatever the value property. Yeah,
Value,
exactly.
okay.
Whatever the value, whatever
Right.
the value is, gets passed as the argument into display. So we're
Okay.
passing in async rocks.
Gotcha.
So that means we're going to do what?
Then console log async rocks.
Exactly.
Okay.
Okay, so we've now wrapped up this function. We have some cleanup, Catherine.
Okay, so garbage collect the local execution context and then pop display off as the call stack.
Exactly. Okay. So now we have to ask, what are the 3 rules, Catherine, that the callback queue and the event loop is asking? What are the 3 rules?
Okay, so it's asking if the call stack is empty except for global, which it is. There isn't any more synchronous code to be run. And then now the microtask queue is empty. So
exactly. So what are we pushing onto? Which function are we pushing onto the call stack?
The print hello function.
Exactly. So that's, I think, this color. No, let's go with this one. Okay, people, this is actually the last one. So let's get a collective shout together. We are invoking a function, so we are creating a new
Local execution
context.
Yes. Okay. Way to end on top. My goodness. Okay, so let's set that up. We got some local memory. Our thread enters. And what do we do, Catherine?
Console log hello.
That's right. Okay, we have some cleanup. What's the cleanup?
Garbage collect the local execution context and pop print hello off of the call stack.
Exactly. Okay. Catherine.
Thanks.
Wow. Well done. Way to really wrap that up for us so nicely and put all of the pieces we've learned together. Excellent job. Truly excellent job. Okay, people. Wow. What a trip. We just combined all the things. And so this slide is really telling you that promises not only are more readable than callbacks. I mean, this is really the modern way you're going to write asynchronous functionality. But there's additional little benefit you get over callbacks with promises, which is the microtask queue gets priority over the callback queue. Still has to follow the 2 rules. You know, is the call stack empty besides global? Is there more synchronous code to run? But the callback queue has to check if the microtask queue is at roll. Rather, the event loop is checking this for us. But the event loop's checking, okay, we have stuff in the microtask callback queue. We could have 30, functions in the microtask queue, 1 on the callback. It doesn't matter. The microtask queue has to be empty before we even consider the callback queue and what's in there. Just the rules. So with that, we're going to go to, actually, Robin, I'll get to you in a second. We are on the last slide. Keep your hand up, and then I'll get to questions. Okay. So people, now we can delay functions running until the work is done and data is available. We do this with the help of promises, the web API, callbacks, the microtask queue, and the event loop and callback queue. However long it takes. We can't write synchronous code and just wait for our response to come back. We don't know how long it takes, so we let JavaScript handle this for us. Essentially, like I said earlier, one of the trade-offs with having the ability to run asynchronous code in JavaScript is we don't know exactly when this data is going to come back, but we can write functionality that says, when it comes back, this is what I want you to do. And this stuff happens quick. I mean, if you go to like Amazon.com, your browser is making like 350 requests for data. And that's how, you're still scrolling all over Amazon and things are working for you. Things happen quickly, but it's because of asynchronous JavaScript that we can do things like, work and interact with pages without feeling like, it's frozen, right? In addition, it's non-blocking, which means we don't have to wait for the thread, right? Our thread doesn't get blocked with asynchronous code. We pass it off to the browser does the work for us, our thread continues. And again, this is what allows us to have the modern web. If we didn't have asynchronous code, websites would not be fun, I promise you. All we would be doing is looking at a bunch of, static sites and, Wikipedia pages, basically. Because of asynchronous JavaScript on the web, we can have really fun and entertaining and, kind of like wild experiences with our browser and websites. Thank you so much for hanging out and learning with me. I really appreciate it. It's such a blast. You guys were so amazing. I hope to just see you at, other workshops. So just keep coming around, and nice to see you all, and have a wonderful night and a wonderful rest of your week.